the last lecture we have seen the example based on three-dimension geometry, line, plane. The last example that we have solved that is the angle between the straight lines, that ninth example. The relation between the direction cosines of the two lines are given by certain relation, and with the help of them we have obtained, that is a DRS of these two lines, and then we have obtained the angle between these two lines. Similar example is here in your 12th example, and you can solve like this also. In the 12th example you can find the value of m and continue as above. You get that final answer, that cos inverse 1 by 6, that is B choice is your answer for the 12th example, 12th number example. Be careful about it. The same example of same as to example number 9. Find out the relation and get the DRS of these two lines, and then use the formula cos theta is equal to mod of a1 a2 plus b1 b2 plus c1 c2 upon root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square, and get it answer cos inverse 1 by 6 there, right? Okay, now we shall deal with example number 11 in your sheet, that is triangle ABC. Example number 11, triangle ABC, A, (2, 3, 5), B, -1, 3, 2, and C, lambda 5 and mu is given there. If the median through A, a segment joining midpoint of, that is median through A, that is equally inclined to the axis, that is AD is a median, AD is a median, that is equally inclined to the axis, equally inclined to the axis, then we have to obtain the value of lambda and mu. See that A is there 2, 3, 5, BC. Now D, AD is a median, so D is a midpoint of BC. By using midpoint form of section formula, coordinates of D, that is lambda -1 upon 2, 5 plus 3 upon 2, mu plus 2 upon 2. So these are the coordinates of point T by using midpoint formula. Now we shall find the DRS of AD, and then from the DRS we shall obtain the DCS of AD. See our plan. First of all, we know the coordinate of point D. Now we shall find the DRS of AD. With the help of DRS, we shall find the DCS. DCS means cos alpha, cos beta, cos gamma. And as it is given that the line is equally inclined with the coordinate axis, that means alpha is equal to beta is equal to gamma. Therefore, cos alpha is equal to cos beta is equal to cos gamma. We can compare there, and after all that, then we shall find the value of lambda and mu. Listen, now DRS of AD, lambda -1 upon 2 minus 2, then 5 plus 3, 8 upon 2 is 4, 4 minus 3, then mu plus 2 upon 2 minus 5, that is 2 2s are 4, minus 4 plus 1, lambda minus 4 plus 1, right, minus 4 minus 1 minus 5 upon 2, 1 mu plus 2 minus 10 upon 2, that is lambda minus 5 upon 2, then 1, then mu minus 8 upon 2. These are the DRS. DRS of AD. Right? Now, DCS of AD, that is L is equal to cos alpha is equal to lambda minus 5 upon 2 upon, this is a root of lambda minus 5 upon 2 bracket square plus 1 square plus mu minus 8 upon 2 bracket square. This is the value of L cos alpha. M is equal to cos beta is equal to 1 upon same value lambda minus 5 upon 2 bracket square plus 1 square plus mu upon 8 upon 2 bracket square. No need of simplifying it because we are going to compare L is equal to M. Automatically it will be cancelled. Right? Then N is equal to mu minus 8 upon 2 upon same value root of lambda minus 5 upon 2 bracket square plus 1 square plus mu minus 8 upon 2 bracket square. Now it is given that since AD is equally inclined with coordinate axis, therefore L is equal to M is equal to M. And obviously, therefore, denominator is same, so therefore we can directly lambda minus 5 upon 2 is equal to 1 is equal to mu minus 8 upon 2. Lambda minus 5 upon 2 is equal to 1 is equal to mu minus 8 upon 2 because we have the common denominator on this side. Therefore, we can compare lambda minus 5 upon 2 is equal to 1 and mu minus 8 upon 2 is equal to 1 and therefore lambda is equal to 2 1s are 2 plus 5 7 and mu is equal to 2 plus 8 that is 10. So lambda is equal to 7 and mu is equal to 10. C choice is your answer. No need of writing the denominator because we have the same denominator, so automatically it will be cancelled while comparing there, so directly we can get it. Okay, right. Next, the foot of the perpendicular, example number 13. Example number 13. The foot of the perpendicular drawn from the point A, 1, 8, 4 to the join of the B and C. The join of B, there is a line joining B and C. B and C. B is 0, minus 11, 4 and C is 2, minus 3, 1. What is asked that? The foot of the perpendicular drawn from point. From A, draw perpendicular. Yes. Let P be the foot of the perpendicular and it is asked to find the coordinates of point P. Let P divides BC internally or maybe in the ratio lambda s to 1, say lambda s to 1. Therefore, by using section formula, of point P, coordinate of point P, that is lambda into 2, 2 lambda, plus 1 into 0, 0, upon lambda plus 1, comma, here, lambda into minus 3, minus 3 lambda, plus 1 into minus 11, minus 11, upon lambda plus 1, lambda plus 1. And third, that is lambda into 1, lambda, and plus 4 upon lambda plus 1. These are the coordinates of point P. Now, listen, DRS of AP is equal to DRS of AP. Why we are finding the DRS of AP? Because AP perpendicular to this one. We know we can find the DRS of BC also. And when DRS of BC and DRS of AP, they are perpendicular. Therefore, their product is equal to 0. A1, A2 plus B1, B2 plus C1, C2 is equal to 0. So, DRS of AP is equal to 2 lambda upon lambda plus 1 minus 1, comma, minus 3 lambda minus 11 upon lambda plus 1 minus 8, comma, here third, lambda plus 4 upon lambda plus 1 minus 4, that is 2 lambda minus 1 upon lambda plus 1, comma, minus 3 lambda minus 11 minus 8 lambda minus 8 upon lambda plus 1, and here lambda plus 4 minus 4 lambda minus 4 upon lambda plus 1, that is 2 lambda minus lambda, lambda minus 1 upon lambda plus 1, minus 3 lambda minus 8 lambda minus 11 lambda minus 19 upon lambda plus 1, and here last lambda minus 4 lambda minus 3 lambda, 4 cancel, upon lambda plus 1, that is DRS of AP. DRS of AP. Now DRS of AP, what is the DRS of BC we can find first? DRS of AB, DRS of AB, that is 2 minus 0 minus 3 minus of minus plus 11 and 1 minus 4, so that is 2, 8 minus 3. Since AP perpendicular BC, it is BC, DRS of BC, AP perpendicular BC, therefore A1 A2 plus B1 B2 plus C1 C2 is equal to 0, the property, that is 2 into lambda minus 1 upon lambda plus 1 plus 8 into minus 11 lambda minus 19 upon lambda plus 1 minus 3 into bracket minus 3 lambda upon lambda plus 1 is equal to 0. Common denominator lambda plus 1 cancel there. So therefore 2 lambda minus 2 minus 88 lambda, yes, minus 152 plus 9 lambda is equal to 0. Therefore minus 88 lambda plus 9 lambda becomes a minus 79 lambda minus 79 lambda and plus 2 lambda minus 154 is equal to 0. Therefore, minus 77 lambda is equal to 154, and therefore lambda is equal to 154 upon 77 minus lambda is equal to minus 154 upon 77. What is asked? That we have obtained the lambda, the foot of the perpendicular. We have to find the coordinates of point P. Now we shall find the coordinates of point P. What are the coordinates of point P? The coordinates of point P is equal to 2 lambda plus 0. Observe here, yes, that is 2 into minus 154 upon 77 upon minus 154 upon 77 plus 1 comma minus 3 into minus 154 upon 77 minus 11 upon minus 154 upon 77 plus 1, and here minus 154 upon 77 plus 4 upon minus 154 upon 77 plus 1 is equal to, that is 2 into this one, that is minus 2 4s are 8, 2 5s are 10, 2 1s are 2, 308 upon 77, here also upon 77 it is cancelled, upon minus 154 plus 77 here, plus 3 4s are 12, 1, 3 5s are 15 plus 1, 16, 1, 3 1s are 3 plus 1, 462 minus 11 7s are 77, 7, 11 77 plus 7, 847 upon minus 154 plus 77, comma here, that is minus 154 plus 4 7s are 28, 2, 4 7 28, 308 upon minus 154 plus 77 is equal to minus 308 upon, yes, that is 77 comma here 5 8 385 upon 77 here 4 5 1, that is 5 is 5, 154 upon 77, here is a sign minus, here is a minus, here is also minus 77, here minus 77, here minus 77, right, is equal to, yes, 77 4s are 308 comma, that is 77 5s are, and 77 2s are, that is plus, that is plus, that is minus 4 5 minus 2. D choice is your answer. Take care of that. Observe these calculations. You must be in the position, you must be confident about it, how to do the calculations. Correct? Don't lose your confidence. Because while this type of calculations are occurred, sometimes students leave the example only due to that calculation. But be confident, you'll get your answer correctly. If you do it properly, if you do it with the help of rules, then you'll get your answer. Be confident about it. Okay, next, that is the foot of the perpendicular, example number 14. The foot of the perpendicular from the origin to the join of A minus 9, 4, 5 and B 11, 0, minus 1. Right. The foot of the perpendicular from the origin, that is say P, and find the ratio in which it divides. It's a very easy actually. Yes, see that. The previous example that now we have solved. OP is the length of the perpendicular drawn from it. Now let P divides AB in the ratio lambda as to 1. Correct? Continue as above. Find the coordinate of point P. Right? Find the DRS of OP. DRS of AB, just now we have calculated the DRS of OP, DRS of AB, they are perpendicular to each other. Find their product A1, A2 plus B1, B2 plus C1, C2 is equal to 0. Find out the value of lambda. Lambda, you want only ratio, so that is lambda give you. So for example, lambda comes at 2 upon 3. So it's a 2 upon 3 as to 1 means 2 as to 3. 1 upon 2 as to 1 means 1 as to 2. So in this way only you find, that is your, you try yourself, yes, like the same way to find the coordinates of like this, okay, right. Now I am giving you some more examples, like listen. Example number 17, see, example number 17. The equation of the line passing through the point, equation of the line passing through the point I minus j plus k and parallel to the line, this line, required line, parallel to the line, joining the points with position vector, say B and say C with position vector B minus I plus 4j plus k and C here I plus 2j plus 2k. Yes. Now this line, this is a required line whose equation is to be obtained, and this line is parallel to this one. So B has a coordinate minus 1, 4, 1. C has a coordinate 1, 2, 2. Therefore, DRS of BC, that is 1 minus of minus 1, comma 2, minus 4, comma 2, minus 1, that's equal to 2, comma minus 2, comma 1, basic. Now since required line L is parallel to BC, therefore we considered the same DRS. Therefore, DRS of line L, DRS of line L can be taken 2, minus 2, 1, or in proportion with 2, minus 2, 1. correct? 2 minus 2, 1. Now DRS is known, and required line passing through A 2 minus 1 1, and DRS is known. Therefore, in which form you required? The equation of this line, you require, therefore, using the symmetric form, that is x minus x1 upon A is equal to y minus y1 upon B is equal to z minus z1 upon C, and therefore x minus 2 upon 2 is equal to y minus of minus plus 1 upon minus 2 is equal to z minus 1 upon 1. This is the required equation of line x minus 2 upon 2, y plus 1 upon minus 2, z minus 1 upon 1. This is your A choice. This is example. Right? Yes. Observe the example number 24. 24 for the plane actually. The vector equation of the plane, 24 example. The vector equation of the plane through the point 1, 1, 0, comma, 2, 3, 2, 2, 3, 2, and parallel to the line, x minus 1 upon 1 is equal to y minus 1 upon minus 2 is equal to z minus 2 upon 3 is. We have to find the equation of plane. Listen here. This is a plane. And this plane passing through points, say A 1 1 0, B 2 3 2, and the line is parallel to, the plane is parallel to, that is x minus 1 upon 1 is equal to y minus 1 upon minus 2 is equal to z minus 2 upon 3. Now see that. Find out the DRS of AB. It is a normal to the plane. We require always normal, whose DRS are always A, B, C, so that we can write the equation of plane as AX plus BY plus CZ plus D is equal to 0 in this way. So we require ABC now. How to find the ABC? Because it is parallel to AB and line L. Therefore, normal is perpendicular to AB and this line. So we know that how to find the DRS of the line which is perpendicular to given two lines. What I told you that in the last lecture, again that is A, B, C, the required DRS. Then DRS of this line 1, minus 2, 3. Then DRS of AB 2 minus 1, 1. 3 minus 1, 2. 2 minus 0, 2. You first write like this, then we shall find the values of A, B, C like this. That is A upon determine here minus 2, 3, 2, 2, comma, minus B upon, drop that, 1, 3, 1, 2, comma, C upon 1 minus 2, 1, 2. So A upon minus 4 and minus 6 becomes a minus 10. Minus 4, minus 6, comma, minus B upon 2 ones are 2, minus 3 becomes a minus 1. C upon 2 1s are 2, minus of minus plus 2. 2 plus 2 becomes a 4. So therefore, A is equal to minus 10. B is equal to 1 because minus B is equal to minus 1. C is equal to 4. So they are the DRS of the normal. DRS of normal to the plane. With the help of this also you can directly write like this. Therefore, equation of plane AX plus BY plus CZ plus D is equal to 0. Therefore, minus 10x plus y plus 4z plus D is equal to 0. Say equation number 1. Now to find the value of D, simple form there. Don't use any form other. Just take any point. The A lies in it, coordinates satisfy the equation, get the value of D there. Since point A lies in it, point A lies in it, therefore minus 10 into 1 plus 1 plus 4 into 0 plus D is equal to 0. Therefore minus 10 plus 1 plus D is equal to 0. So D is equal to 9. And therefore from 1 minus 10x plus y plus 4z plus 9 is equal to 0, or change the sign, 10x multiplying by both sides minus 1, 10x minus y minus 4z minus 9 is equal to 0. It is a Cartesian form. If you want a vector form, that means only r bar dot into bracket DRS, that is 10i minus j minus 4k bracket complete minus 9 is equal to 0, or r bar dot into bracket 10i minus j minus 4k is equal to 9. It's a vector form. Observe there which form is given there. So that is given equation is in the vector form. R bar dot into bracket 10i minus j minus 4k is equal to 9. C option is the correct option. Both the forms you have given there. That is a Cartesian form as well as that is a form which is a given. It is the vector form. So you can form this equation with the help of like this also. Not necessary that you must know each and every form of the plane, because we required only the DRS of normal to the plane and any point from that, so that we can form the equation there. Okay, right. Listen here. Example number, I'm taking from the last actually. The 46 formula we required there, 46 there. The image of the point, the image of the point 1, 3, 4 in the plane x plus 2y minus z plus 3 is equal to 0 is, that is, observe here. Now image, you have a lot of work to find the equation and etc. I am giving you a short method. That means I am giving a direct formula to find the image of that. The formula is there. If alpha, beta, gamma, listen, alpha, beta, gamma is image, is an image of x1, y1, z1 in the plane ax plus by plus cz plus d is equal to 0, then you use like this, that is alpha minus x1 upon, alpha minus x1 upon a is equal to beta minus y1 upon b is equal to gamma minus z1 upon c is equal to minus 2 into bracket ax1 plus by1 plus cz1 plus d upon a square plus b square plus c square. Use this formula directly here. Right. Listen here. Now, whose image is to be obtained now here? 1, 3, 4. Let alpha, beta, gamma be the image. Now what is here? What is the DRS? A, B, C are DRS of normal to the plane there. So therefore, alpha minus 1 upon 1 is equal to beta minus 3 upon B means 2 is equal to gamma minus 4 upon C means minus 1 is equal to minus 2 into bracket, substitute there x1 as a 1 plus 2 into 3 minus 4 plus 3 upon a square plus b square plus c square, and therefore we have alpha minus 1 upon 1 is equal to beta minus 3 upon 2 is equal to gamma minus 4 upon minus 1 is equal to 3 2s are 6, 6 plus 1 7, 7 minus 4 3, 3 plus 3 6, 6 into minus 2 minus 12 upon 4 plus 1 6, 6 into, that is a minus 2. Get it separate and find out the values of alpha, beta, gamma. Therefore, alpha minus 1 upon 1 is equal to minus 2. Beta minus 3 upon 2 is equal to minus 2. And gamma minus 4 upon minus 1 is equal to minus 2. Therefore, alpha is equal to minus 2 plus 1, beta is equal to minus 4 plus 3, gamma is equal to 2 plus 4. So alpha is equal to minus 1, beta is equal to minus 1, gamma is equal to 6, and therefore the image is minus 1, 6. Therefore, image is minus 1, 6. Choose your choice. That is, B choice is your answer. I took an example precisely because so many students don't know exactly how to find the directly image of that. So remember that alpha, beta, gamma is an image of x1, y1, z1 in the plane ax plus by plus cz plus d is equal to 0. Then remember this result. This will give you a very easy form to find the image there. Right. Followed? Right. Next, example number 45. Example number 45. The distance between the parallel planes, 2x minus y plus 3z minus 4 is equal to 0, and 6x minus 3y plus 9z plus 13 is equal to 0. These are the two planes, right? whenever you want distance between two parallel planes, remember that the coefficient of x, y and z must be same. And you can make the same since they are parallel. Otherwise you can't do it. Listen here. So what to do? Divide the second equation by 3, right? Dividing by 3, both sides. 2x minus y plus 3z plus 13 upon 3 is equal to 0, right? So this equation becomes, now observe there, A, B, C, they are same. Now when you have the two planes parallel, that is AX plus BY plus CZ plus D is equal to 0, and AX plus BY plus CZ plus D dash is equal to 0. ABC are same, then distance between them is equal to mod of D minus D dash upon root of A square plus B square plus C square, and that's equal to here, right? What is a D? Minus 4 is a D. What is a D dash? 13 upon 3. So mod of minus 4 minus 13 upon 3 upon root of, what is the A square? 2 square 4 plus minus 1 square 1 plus 3 square 9. That's equal to 3 4s are 12 minus 13 mod of minus 25 upon 3 into root of 14, and that's equal to 25 upon 3 root 14 is the required distance between the parallel lines. So what is given? 25 upon 3 root 14. B choice is your answer. B choice is your answer. Correct, right? A plane AX plus BY 105 contain the line so and so. The point 21 minus 1 is at a distance of 1 upon root 6 from the plane. Then A plus B plus C. The value is given A plus B plus C. First of all, that is two planes are given. Example number 44. That is 2x minus y plus z minus 3 is equal to 0, one plane. 3x plus y plus z minus 5 is equal to 0 also on that plane. Two planes. Then two planes intersect, the line form. Correct? That's why equation is given. So we required a plane. So equation of plane is given with the help of them. Equation of plane, that is in first bracket 2x minus y plus z minus 3 plus lambda into bracket 3x plus y plus z minus 5 is equal to 0. Remember that P1 equal to 0, P1 equal to 0 and P2 equal to 0 are given two planes. Then the equation of plane passing through intersection of P1 and P2 is equal to 0. Equation of plane passing through intersection of P1 and P2 equal to 0 is given by the locus P1 plus lambda time P2 is equal to 0. So I've used this concept here. That is number 1. I'm going to simplify this equation as like this. That is in bracket 2 plus 3 lambda into x plus into bracket minus 1 plus lambda into y plus into bracket 1 plus lambda into z plus into bracket minus 3 minus 5 lambda is equal to 0. I have collected the terms of x, y, z and etc. What is given condition? The point 2, 1, 1, 1 minus 1 is at a distance of 1 upon root 6 from the plane. That means this is a plane. Its distance from the point 2, 1 minus 1 is 1 upon root 6. So distance, how to find the distance? Distance of point from plane, that is point x1, y1, z1, plane ax plus by plus cz plus d is equal to 0. So distance is equal to mod of ax1 plus by1 plus cz1 plus d upon root of a square plus b square plus c square. This formula is there. So what is the distance? Distance is 1 upon root 6 is the given distance. Therefore, mod of, that is ax1, that is point is given. What is the point? Say given point is 2, 1, minus 1. 2, 1, minus 1. It is a point. So therefore, 2 plus 3 lambda into 2 plus minus 1 plus lambda into 1 plus 1 plus lambda into minus 1 plus in bracket minus 3 minus 5 lambda upon root of a square. 2 plus 3 lambda bracket square plus into bracket minus 1 plus lambda bracket square plus 1 plus lambda bracket square. This distance is equal to 1 upon what is given, root 6, and therefore mod of, observe there, 2 2s are 4 plus 6 lambda minus 1 plus lambda minus 1 minus lambda minus 3 minus 5 lambda upon here 4 plus 6 12 lambda plus 9 lambda square plus 1 minus 2 lambda plus lambda square plus 1 plus 2 lambda plus lambda square. This is totally in the root, yes, is equal to 1 upon a root 6. And therefore, mod of 6 lambda, 7 lambda, lambda cancel here, and there 6 lambda minus 5 lambda becomes only lambda, right? And here minus 1, and minus 3 becomes a minus 5, minus 1, minus 3, minus 5, and plus 4 becomes a minus 1 upon here root of, what we get there, that is 9 lambda square, that's equal to 11 lambda square. Then 12 lambda minus 2 lambda plus 2 lambda, it is cancelled here. So we get the plus 12 lambda, plus 12, 4 plus 1, 5, 5 plus 1, 6, that is plus 6 is equal to 1 upon root 6. 1 upon root 6. So therefore, yes, squaring both sides here, lambda square minus 2 lambda plus 1 upon 11 lambda square plus 12 lambda plus 6 is equal to 1 by 6, and therefore 6 lambda square minus 12 lambda plus 6 is equal to 11 lambda square plus 12 lambda plus 6, and therefore transfer on this side 5 lambda square, transfer on this side plus 24 lambda, 6 cancel is equal to 0. Take out the lambda common into bracket, 5 lambda plus 24 is equal to 0, and therefore lambda is equal to 0 or lambda is equal to minus 24 upon 5. In this way we find the lambda, both the values here. After substituting this value in the given plane, that is here or here, you substitute there, you get the two equations. And you get this equation such that their right side should be equal to 105. because we had to compare. So this is the equation. See that I'm going to substitute this value in the first equation, that is lambda is equal to 0. Putting the value lambda is equal to 0 here, get 2x minus lambda plus z minus 3 is equal to 0. Therefore 2x minus lambda plus z is equal to 3. But for the comparison, a plane ax plus by plus cz is equal to 105. That means right side should be 105. So therefore here we have to multiply by 35. So 70x minus 35 lambda plus 35z is equal to 35 3s are 105. This is my first equation. And when I am going to substitute the lambda is equal to minus 24 upon 5 in a bracket 2x minus y plus z minus 3 minus 24 upon 5 into bracket 3x plus y plus z minus 5 is equal to 0. 5 2s are 10, 24 3s are 72, minus 72 and plus 10 minus 62x minus 5y and minus 24y minus 5y and minus 24y minus 29y. And then 5z here and minus 24z, that's equal to 5z and minus 24z minus 19z minus 15 here, minus 15 and plus 120. Automatically I get here minus 62x minus 29y minus 19z plus 105 becomes a minus 105 there. Change the sign. 62x plus 29y plus 19z is equal to 105. Observe their right side. 105 because equation is given. ax plus by plus cz is equal to 105. Then find the value of a plus b plus c. So here a plus b plus c is what? 70 minus 35 plus 35, that is equal to only 70, and here 62 plus 29 plus 19, that's equal to sorry, yes, that's good. 110. So 70 and 110. These are the values. Observe there in the choices which value is given there. So C choice 70 is there. I have given this example for that sake. See that. Be confident about it. Although there are the large calculations also, but be confident about it. Do it properly. You'll get your answer there correct. So I'm just trying my level best to give you almost all about the plane, line and 3 dimensions there, right? Next time also we shall take some examples and also we shall take the trigonometrical problems, solving the solutions and etc. Okay? Yes. If any queries are there, if any problem is there, after also in this examples also or some examples in this sheet also, you have some complete about it. You do it one thing that you give your whatever your difficulty is there in our class, so that we shall give you at our level best to provide you almost all the difficulties clear. Wish you all the best. Yes.